So those that did get these glued in, they're card sorts. If you did not, it's going to be on our video. Go ahead and put it in, and I will give you part of the Starbucks for it as well. Functions. With the pencil test, that one would be a function. Vertical line going across that line would only touch in one place. This one, it's a U shape, but it's still a function because it would only touch on one place on the line. Here, every input only went to one output. Inputs, -3, -1, 5, 8, they only had one output. Same thing on this table. We had our coordinates. I looked for my x, -3, -2, -1, 0, 1. They only had one output. Same thing in our table, and same thing with this output. You do notice that on this one, we have a -2, 1, and a -2, 1. That's still a function because the -2 went to 1. Even though it got repeated, -2 did not go to a different output. It went to the same input or output. These, I highlighted why they were not a function. Circle, the line test, it would hit in 2 spots. Curvy S line, it hit in 3 spots at one time. We have 4 to go to 3 and 4 to go to 2. My input went to 2 different numbers. I cannot have 2 answers for my input. Up here, I only have an input of -1, and it had 5 different answers. Cannot have that. 3 and 4 both had 2 answers for their output. Cannot do that. 5, 1, 5, 3. My x, my input, had 2 answers. Not a function. 1, 4, 1, 2. My input had 2 answers. Cannot have that. That was our biggest goal from yesterday, was remembering that a function can only have an input going to one output. So, we're going to do a couple things. Open up, please, your notes, your foldable. Open up to yesterday's vocabulary. We're going to finish one part there, the exit ticket. So finishing up yesterday's, this should take us long. Complete the mapping diagram below so that one does not represent a function, the other does not. So this is in your vocabulary. It's on your purple sheet. Dylan, open up your notes. You can be with us. Isabel, get yours. Kemper, opening up your notes so you're following with us, bud. Alright, so who thinks they could come up to the board? I want everyone to try and do one in their notebook, but who could come up to the board and make the first mapping diagram? I have inputs -8, 0, 8, 16. Outputs are -4, -2, 0, and 2. We got to make a mapping diagram. Remember, that's where you draw your line from your input to an output. Who thinks they can come up and make this one so it's not a function? It is not a function. Will, do you think you can do it? Let's see what you get. Okay, 8 went to -8 went to -4. Perfect. This one is not a function now. -8 went to -4 and -8 went to -2. My input had 2 answers. That is not a function. You could have done yours any way you want, as long as -8, 0, 8, and 16, that number went to 2 different outputs. How about making this next one a function? Same mapping diagram. Can we make it a function? Does someone else do this one? All right, Evan. There you go. Simple as that. You just missed your subject. Ooh, that one's open. I think I got one left. Well, alright. So that is a function because every input had one answer. let's look at today's. So today for 7.2, we are going to look at representations of functions. Yesterday we did, if I get all the top, relations of functions. We learned what a function is. Today we're going to learn how to represent it. If you go to the warm-up, I think it's in your notebook. Turn the page. It's that. Yep. I think it came right after. Right after your foldable. 7.2 warm-up. It's about as slugger as I'll give out some Starbucks today. But, number one, input values can be English, any English word. Output values are letters from the English alphabet. I'm going to go to here on my OneNote just because it's easier. But this matches up with yours. So, inputs are any English word. Outputs are letters from the English alphabet. I want to know what is the rule that would produce the given output. So when I said cat, T came out. House, E came out. U came out. Stem, what would come out? Dylan? Okay, so let's make sure we write this. M. Z came out. Pez. Uh-huh. How about, I need two more examples. What would be two examples? A word, and then what would be the outcome? Will? Put zoo. The zoo. And I'd get an O. And Isabel? Silver. I get an R. Okay, for my Starbucks point, who can tell me what is going to be my rule? Okay? So we would say output, let's write this down, is last letter of input. So whenever I put in the input, my output would be the last letter. Let's look at number 2 then. Inputs can be any rational number. Output values can be any rational number. Well, the Starbucks, can we figure out what is the rule? What's the rule? Jordan? Good. So once again, we have to say our output is plus 5 of input. Go ahead and on your sheet, fill in those blanks. I'm going to have a better way to look at this. Easier to track these. Okay, so if negative 4 went in, what would come out? 1. What went in if 8 came out? Good, backwards. And I need an example of it.
4.
Evan?
6 for the input and the output would be 11.
Good. So we're following our rules. Last one. Input values can be any whole number between 1 and 365. Output values can be any month of the year. Don't shout it out. You can figure out this rule. This one's a little tricky. 25 is January. 365 December. 35 February. 95 April. 330 is November. Dusty?
September.
66 is not December.
No, I didn't say December. I said September.
Huh?
September.
For this?
Yeah.
No. 66 went in September would not come out.
March. Oh, I was just saying that.
Oh. It would be March. What is the rule? Date?
So like every day, like past like the first day of the year, it's like the month. So the 25th day of the year would be January, and then you can go the 35th would be February, and the 66th would be March. Because it's like I don't really know, but it's like starting from number one, and you keep going, and you don't like cut the days off of the month, and you just keep going.
Output is the month the day is in. And then we start with day 1. 1, 2, 3. In January, there's 31 days. So 1 through 31 would go to January. 32 would actually be February 1st. So you would have to count all this. I don't want to take the time to count October. But we found out March because 31 was January. 28 is in February. So that's only 59 days. So the next 66, the next 7 days would have been in March. Would have been the first week of March. All right. Let's go back in your foldable. Go back to our foldable. We are going to be going to representations of functions. A function can be represented by an input-output table and by a graph. We're actually going to learn a lot of ways that we can show functions. So an input-output table and by a graph. This, actually the first part, is an input-output table. It's very simple. One column is my input. The next one's my output. And we saw these yesterday. So 1 goes in, 3 came out. 2 goes in, 4 comes out. 3 goes in, 5 comes out. All you do is you make your table. So if I was to draw this again, I'd simply do this. This is my input. I'd say my output. So that's X, that's Y. And then I just put my values in. A lot of times we'll see input-output tables change a little bit. This one, we added step to next row because we knew we were going to graph it. So I added another column just to organize and put my ordered pairs there. Some people, when they make their input-output table, they'll go input, they'll write the rule, and then they'll do the output. And we're going to see one of those. But this is an input-output table, and now to graph it. Well, to graph anything, at the bare minimum, if I didn't know my y-intercept or anything, I need 3 points. Because 3 points gives us a straight line. So if I look at my input, and I had 1, and output was 3, that means my ordered pairs, x, y, is 1, 3. So they went to this grid paper, and I just put down the coordinate point, 1, 3. My next input-output, 2 went in, 4 came out. So I have the coordinates 2, 4. 3 went in, 5 came out. So I have coordinates 3, 5. We then draw our straight line. Now, by drawing a line through the points, we have every solution to this input-output table. So before, even if I don't know the rule, if I had to add on to this, I didn't know what my rule was, I could look at my table, my line, and go, okay, well, I can tell I know this point. That point is 4, 6. So that means my input number was 4, my output number was 6, because my coordinate was 4, 6. Anything that falls on that line will work in my function table. Now, opening up your booklet, representations of functions, we are going to do this together. So I want to do the first one together, then I'm going to have you guys kind of work on your own, see if you can do it. It says graph the function y equals negative 2x plus y. I'm sorry, plus 1. Good question. Could I graph this right now without my input-output table? Yeah, because this equation told me my slope is negative 2 and my y-intercept is 1. So I can check this later. But it tells me I have to do an input-output table. This input-output table is a little more complex. We still have our input, and we still have our output, but they added in our equation and then our ordered pairs. So we're going to do all of that. It told us to use these for my input. The input values of negative 1, 0, 1, and 2. So in your booklet, let's go ahead and do that. I'm going to write negative 1, 0, 1, 2. Now, besides them telling me to use those numbers, is there any real reason I have to use those? Yeah. I could have used any numbers I want. The reason we use negative 1, 0, 1, 2 is those are the easiest numbers to work with. I could have put 23, 56, 89, 567, but then that's just a large number to work with. These are always the easiest. The next step, after you put your input, is to apply it, and we're going to show our work. So x, so I'd still say y equals negative 2 times x. So x is negative 1. So I ran out the equation, but I substituted in my value for x. Yes, Dusty? Okay. So I go ahead and I keep solving this. I'm not going to say y equals negative 2 times negative 1 is 2, and 2 plus 1 is 3. Y equals 3. My input's negative 1. My output is 3. So my ordered pair is negative 1, positive 3.
Haven't we done this before?
Something very similar to it. Yep. I like that you caught on to that. We've done this stuff before when we didn't call it input-output table, but when we gave you guys a function or a rule, we had to graph it, and we used that table. We did exactly like this. So it should be a pretty easy review today. I like that you remember that. That's good. So we go to this one. Y equals negative 2 times x. X was 0 plus 1. Well, negative 2 times 0 is 0. And 0 plus 1 would give me 1. We have 0, 1. To do number 1, write our equation down again. Y equals, I keep going back to this equation they gave me. Y equals negative 2 times 1 plus 1. Negative 2 times 1 is negative 2. And negative 2 plus 1 is negative 1. Oops, I should have switched colors when I did that. My coordinates, x is 1, y was negative 1. Last one, y equals negative 2 times 2 plus 1. So y equals negative 4 plus 1. Negative 4 plus 1 is negative 3. So we have the coordinates 2 and negative 3. Once you have all this, all we have to do is now graph the ordered pairs and make our line. So I know my ordered pairs were negative 1 and 3. Negative 1 up 3. 0, 1. 1, negative 1. 2, negative 3. Should be in a line. Oops. one's better. We'll use this. So then I have my line. Alright, I'm going to check something with you guys. And this is going to be with your Starbucks. Can anyone, looking at their graph, give me one more input and output that should work? By looking at the graph. Sydney? Okay, what about -2? So if -2 is my x, what should be my y? What should be my y coordinate? -2, 2. Well, if we did that, that'd be -2, 2. Is that on our line? So what other point would have to work? Confused? All right, well, let's see if someone can help us. Dusty? Okay, 3, -5. It should be, whoop, I'm a little off, but here's 3, there's -5, it's on our line. Let's see if that works. So we think it's 3. Dusty thinks 3 and -5. If we check it, y equals -2 times 3 plus 1. So that'd be -6 plus 1. -6 plus 1 is -5. So you should see there that if you choose any point on the line, it would work. If my line's straighter, that's even better.
Our lines are not even straight.
Should be as. That's why you should use a ruler to make it as straight as you
We put it in
can.
our notebooks, so like the spiral.
Oh, kind of hitting it. Alright, so here's what we're going to do. We're going to pause our video, and I want you guys to work on this. We're almost done with this. We should do it pretty quick. Input numbers, they told us, let's use, I'll give you the numbers to try. Let's use -1, 0, 1, 2. I'm going to get Starbucks out. Can you find what is the y coordinate? So, show your work here, come up with your output, and then we'll graph it together. Okay, so I'm going to check answers, then I'll show the work with you. What did you get for the y when it's -1? Jordan? Oh, no. Okay, we got 3. What about when it's a 0? 0. What about when it's 1?
I got -3.
And when it's 2?
6.
Alright. For the Starbucks, one of those is incorrect. Raise your hand. See if you can figure out. I have one that is incorrect. Brett? Why is the last one wrong?
Because 2 times -3 is
Very good. So, this one should have been our negative. Showing your work, you should have just done this. Y equals -3 times x, which is -1. -3 times -1 is 3. Y equals -3 times 0 is 0. Y equals -3 times 1 is -3. Y equals -3 times 2. We get -2, 6. That's the right answer. My ordered pairs, -1, 3, 0, 0, 1, -3, and 2, -6. Last thing you have to do is graph these points. 1, 3, and then a 1, negative 3. Okay, make sure you draw your lines because remember your line will show you any possible answers. Okay, almost done with this. Biggest thing is summary representation of function. We have 5 ways we can show a function. 1, we can just put it in words. The output is 2 more than the input. That's our function. The output is 2 more, which means to add 2 to my input. The equation we could write would have been y equals x plus 2. Remember, x is your input, y is output. So when I have the equation, I'm saying my output equals my input plus 2. Those two matched up. The input-output table. They just drew the little table. Input, which is x, output, or y. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. We did a mapping diagram. Mapping diagrams are so close to an input-output table. It's just you kind of separate your 2 columns and you draw the line. The thing is, your output would not have to be in order because my lines could go other places. And the last way is we could graph them. We knew our coordinates negative 1, 1, so negative 1, 1, 0, 2, 1, 3, 2, 4, and you draw your line. Real fast, because we have to know this. I know this isn't in your notebook. You want to see this. I'm going to give Starbucks for each one of these, and then we will be done. Write a function rule for this statement. So now they're putting these in words. The output is 3 times the input. So when I look at this, I'm going to see the output. What do I say for the output? What represents output? Y. So I'm going to say y means equals 3 times the input. Input is what letter? So how do I show 3 times the input? So 3 times x. Brett, you first, so that's how I'm going to give you the point. The output is 8 more than 7, 1/7 of the output. Ooh, this one's going to be tricky. You're going to have to do these today, so make sure you're following how we do it. The output, so I know that's y, is, that's my equals, 8 more than. What's 8 more than? Huh? Plus it. So 8 more than, so adding 8, then 1/7 of the output. I wonder if that was supposed to say input. The output is 8 more than 1/7 of the output. Oh no, it makes sense. Ooh. How do you think we do this one? This one has a trick to it. The output, so y, is 8 more than 1/7 of the output. Huh? Ooh, good. I could say that, or I'm just going to put this there. He was asking if I divide y by 7. We will end up, but what we'll do first is 1/7, oops, 1/7 of our output is that. 1/7 of y. Now it's 8 more than this. So we would write my output is equal to 1/7 y plus 8. Kind of tricky on that one. And because of the time, I'm going to stop on these 3. All you have to do is substitute. I'm going to show one. Find the value of y when x is negative 5. And we messed up. This is supposed to be an x. So you'd say y equals 6 times negative 5. 6 times negative 5 is negative 30. Alright, for your homework, same thing as yesterday, a completion grade. Make sure you go to your notebook. We are working on 7.2. It is 5 questions long. 1 through 4, write the function rule for the words. We did a couple examples like that. You're going to write the y equals. And then the last one's a UV teacher. They give a scenario. You have to explain what they did wrong. You still have 2 minutes left of class. To be honest, you should be able to get 1 through 4 done. So that is your homework due for tomorrow.